Good morning, I'm Andrea Sanfilippo from NXP Semiconductors. I'm here today to talk about the so-called HiCONNECTS project, which stands for Technologies Integration for Connectivity and Sustainability. The HiCONNECTS projects have been funded under the Horizon Europe KDT Joint Undertaking Framework and started in January 2023 and is supposed to end in December 2025 with a total cost of more than 100 million euros. The project consortium consists of 64 partners, coordinated by NXP Semiconductors, and then we addressed technology at this level between 4 and 8. Publications and additional materials may be regularly published on the website also, you can see below. In my current talk, I will first give an introduction about NXP Semiconductors, which was also the coordinator of a 64-partner consortium, followed by an introduction about HiCONNECTS, how it's structured, the consortium partner, and also the different technology aspects addressed by the project and impacts, not just in terms of the technology, but also in terms of the European policies, followed by the project development itself, for where the project aims, what the project aims to do in the future, including also the research aspect like the pilot lines, and finally the demonstrators. NXP Semiconductors is a company with headquarters in the Netherlands. I myself am based at the research center here in Munich. The company itself is an important player in the semiconductors community, and it's focusing on secure connections. The company itself addressed many different domains, so starting from automotive, including, let's say, the infotainment part, but also the connectivity and the sensing part, especially the wireless part, the industrial part, like the smart manufacturing, the mobile application and consumer. So many smartphones, for example, have many chips from NXP actually inside. The smart home scenarios, smart cities, and finally, the communication infrastructure themselves. By infrastructure, I mean base stations, so chips for base stations, for technologies related to 5G and what goes beyond 5G. The company is been in more than 40 countries, and then there are about 11,000 engineers working on research and development. The project HiCONNECTS consists of 64 parts, I already mentioned. Mostly, let's say, in large part, like large enterprises and SMEs. And about 20% of the partners consist of academics or research institutions. Altogether, they come from about 12 countries in Europe, plus Israel and Turkey. And they address the entire semiconductors value chain in relation to this technologies integration. In particular, we have like the IT infrastructure part, mainly led by NXP, NVIDIA, ST, then the academic centers for, like, let's say, low maturity research, shown here. Then you have integration equipment, modules, and also metrology experts on the left side. And finally, we also have the demonstrators. So in this project, we will address multiple demos, including like public health and safety and autonomous driving in smart cities. HiCONNECTS will address 4 different technology challenges. First of all, as regards IoT and edge computing, currently there is a relatively high latency, power consumption, and also low bandwidth, which hampers real-time applications. As a second point, the connectivity side, especially as regards autonomous driving, if you want to achieve in future level 4 or level 5, it would be very important to achieve a higher performance of radars. As a third point, it's important to consider that going towards smaller nodes, it doesn't mean that the performance will keep up. And also the cost itself might be much higher, and also it's important to consider also the power itself, power consumption. There might be a need then to consider alternative architecture or paradigms which can achieve at the same time higher performance, be cost competitive, and have, let's say, low power consumption. In terms of digital sovereignty, currently the EU market share is about 10%. The European Union is aiming to double that by 2030. That's why it's also very important to have a very cost competitive and high performance solutions. HiCONNECTS will address all these topics, even more. We consist of a development of a heterogeneous integration core, basically chiplets for energy efficient, high performance RF and photonic solutions. These solutions will pave the way to fast transmission for IoT and edge, and also in terms of cloud computing and data centers. And that will achieve a higher level of sensing for L4, which will be pivotal for L4, L5 autonomous driving cars. The technology itself is also pivotal for many different domains, so not restricted to the specific domains, but also for RF solution in general, so 5G beyond, I mentioned already, like a cloud infrastructure, but also connected vehicles, Industry 4.0, smart cities, and many other different scenarios. So you can see the domain application will be very large in the end. It's also very important to consider the societal environmental policies of the European Union, because actually a project will address that. In particular, we can see here we have like digital sovereignty and competitiveness. I mentioned before on the digital autonomy side, the aim of the project to have a future product which is very cost competitive, have low power, and have also very high performance. So which will be expected to boost the EU market share in future. We will address digital health policies, because such solution like connectivity and also fast transmission in data centers will achieve to a much higher efficiency for, like, for example, smart drugs and vaccine development. The cryo-EM workflow, for example, has been used for COVID at the early stage, but also will be very, very important for different applications in the same digital healthcare domain, like autonomous driving, public safety solutions, because this solution can be also applied also for healthcare themselves. Cities of the future, the fact that we can achieve real-time, for example, IoT application and very fast transfer rates in the cloud will also pave the way to much more performance, much higher performance for AI solutions, and this also will pave the way for better performance within the future smart cities domains. Finally, in terms of environmental policies, if you consider that such system will pave the way to, let's say, real-time solutions, much higher resilience against hazards. Some hazards, for example, like wildfires, which are also related to CO2 emissions, damages to the environment. You can see how a solution can also mitigate these kind of problems and potentially prevent such issues. The results of research development activities carried out by the HiCONNECTS project will be eventually exploited in two different, in particular, two different product pillars. One of them is led by NXP. It's related to the wireless part, connectivity, so automotive, in particular automotive radar and 5G goes beyond 5G. The idea is to have a future product which is also at the same time one single chip SoC and antenna, integrated antenna for 77 gigahertz, and also the development of the next generation product for 140 gigahertz radar system, which will be pivotal for autonomous driving L4 and L5 cars. Also, the same technology will be very important for what can be beyond 5G, because we are entering into the domain of beyond 100 gigahertz, so millimeter wave, 5G plus, or even 6G domain. And also, this is also related to the future product in relation to the industrial platform itself, industrial platform called El Mandadero, which is about an enhanced 5G connectivity for many different industrial cases, including, let's say, drones. So as you can see, the exploitation we cover many different domains, from automotive, for Industry 4.0, 5G, even future 6G infrastructure, but also is also related to the IoT, so the edge connectivity, and altogether, since also expertise in secure connection, security aspect will also be embedded into this system. The second pillar is related to mainly to the cloud itself and data centers eventually. So NVIDIA will aim at developing the next generation of smart NICs switch platforms. Thanks to this platform, which is actually based on silicon photonics, the idea is to have achieved a very high capacity, so 1.6 terabyte per second, while at the same time have a substantial reduction in energy. Also for NVIDIA, the application will be, as I mentioned before, about a cloud infrastructure, also edge compute itself, but which might be also very relevant if you consider also HPC, so high performance computing applications. These are the two main product pillars, but we should not forget also that the project itself, we also work on the process. So the advanced manufacturing part actually will be led by ST Microelectronics with other academic partners, including aspects in relation to manufacturability, but also employment of AI capabilities and machine learning to boost the performance of the manufacturing part. So talking about the research and development part, the routine integration itself, the project aims to establish 3 different pilot lines covering the 3 different technology domains, which will be very important for the future devices mentioned earlier on. The first one will focus on RF electronics itself, integrated also with the photonics component. The second pilot line will be focused on a photonics part, which is also very relevant for data centers by NVIDIA. And finally, all these components shall be put into a package. This basically will be focused on the word package 3. Starting with pilot line number 1, the focus is, I mentioned before, like RF electronics or heterogeneous integration. It is also led by FPH. As you can see, there are many different partners involved because eventually you need technology development itself, aside testing, the processing for the layers when you need the flex layers, for example, the testing demonstration, and also need important parts in relation to the methodology and the categorization of the system in order to check if a performance, required performance is achieved, and also the quality of the system, which is also incredibly important. The pilot line itself, we aim at developing a heterogeneous integration electronic pilot line for high-speed broadband electronics. This system will be based on indium phosphide on BCMOS. Since this is a new system, consortium will take care of about the energy consumption itself, but also optimizing the components. That's why also the thermal management part will be very relevant. For example, like diamond material will be also taken into account, for example, for thermal management. Finally, the system will be integrated with the photonic part, which will aim at achieving, let's say, more than 400 gigabaud modules. And this integrated system will be pivotal for future radars, automotive radars, reaching above 100 gigahertz performance. The second pilot line will be fully dedicated to the photonics component themselves, and it will be also in particular pivotal for the development of product by NVIDIA for the next generation data centers. The aim is to develop a 300mm pilot line for next generation optical transceivers and also a silicon photonics platform based on this heterogeneous integration. Within this platform, there will be also indium phosphide-based components, which is also partly developed in pilot line 1. So you can see these pilot lines are deeply interconnected themselves. Since it's also a photonics part, you also need, of course, the lasers parts and the photodetectors themselves. So that's why the aim of this pilot line is also to develop a system for high-speed lasers, so DML and also Mach-Zehnder modules, and also high-speed monolithic receiver and PCIC. This is very important because at the end of the day, this is relatively complex, so you need to integrate these components and also, again, test carefully into the system. So if you want more technical information about the system, follow please the invited talk by IMEC, which you can give more details on the system. The third pilot line eventually will be related to advanced packaging. So once you have an electronics part, electronics and photonics part integrated, of course, it will be important to have a packaging. So far, the current state of the art is about side by side. What the project aims to do is to go beyond that. So the idea is to have a 3D stacking and using 3D fan-out wafer level packaging, which is also integration of the antenna part. So this part will pave the way to a very performance radar for automotive, but also will be very important for, let's say, 5G, beyond 5G, when you talk about more than 100 gigahertz applications system as well, for wireless infrastructure. And also, in this project, we also consider it's also very important to consider components, additional components, like high scaling of interconnects and also the interposer material. So finally, once you have the development of entire 3 product lines, so the aim is to achieving the heterogeneous integrated product, then it will be time to see and put to test in the real-time scenarios. So the project will basically tackle 4 different demonstrators. The first one of them is related to the public health scenarios. I mentioned earlier that cryo-electron microscopy has been instrumental for studying drugs, including COVID. This kind of workflow related to cryo-EM requires the order of terabytes data per experiment, so including acquisition, laboratory, and processing. This means that you need a very high amount of data transfer within the network, and also that you need a high performance, especially high performance, let's say, data centers for that. This also will be relevant in case you need to also incorporate potential solution related to artificial intelligence. That's why the demo will tackle the data management platform, which will have a great boost thanks to the development of technology, mainly led by NVIDIA in this project, and also We will also enable data analysis application in these demonstrators. The second demonstrator is related to public protection disaster relief, led by Centria. This is related to the fact, as also explained in the first slides, that it's very complex scenarios. For example, when you have like a public protection disasters, it's very important to achieve very quick resilience in order to prevent the risk of much more complex scenarios, and also to prevent them. The pitch is very complex because of many different stakeholders. We have, for example, in this case, like large scenario of environmental hazards, you need like sensing, like drones, connected to the network. At the same time, this network should also inform the different stakeholders. And then there's a need also to wait for the decision making and quick reactions. So to achieve all of this, especially if you want to achieve real-time applications, where also the project itself device comes in. So the aim of this demo will be, first of all, to equip a drone with the radar sensing developed by the project, and then to make use of situation awareness scenarios, including, let's say, edge processing and acceleration, to achieve very quick, let's say, processing and connectivity. Also, thanks to the fact that the project itself will work on 5G and beyond 5G connectivities. The third demonstrator is related to smart logistics and digital twin, led by the automotive company Ford. This is mainly related to the fact that there is a need to achieve a high level of manufacturing capabilities within the plant itself. This is also made possible by the use of different platforms like, let's say, ground drones or the like. In order to achieve this kind of scenario, like we have logistics, but also somehow smart manufacturing itself, you have, as in the previous case, you have many different stakeholders again. So you have like the sensors part, like radars, cameras, LiDAR. You also need the connectivity, for example, in relation to the robotics part. And finally, also you need the processing. So in this specific case, actually, the technology from NXP will be, which we will bring in, will be about the El Mandadero platform mentioned before, which is also related to the connectivity itself, ultra-wideband vehicle-to-vehicle, and the 5G itself. And also, the aim of this demo will also to develop a digital twin, which will also be possible thanks to the HiCONNECTS devices. So there will be a real digital twin of in real time of the entire system, and then again, AI will be used also to make, let's say, everything even much faster, to achieve much higher performance as well. The third demonstrators is related to the smart construction connectivity by ULAC. The aim is to create, let's say, a collaborative outdoor robotics and mobility system, making use of 5G connectivity. In the end, also the system maybe is less complex than the earlier one, but at the end of the day, you have to deal with the scenario of communications. So you have like core network base stations, but also have, let's say, the trucks themselves and also the sensing part as well. Then again, you have to bring together, on the one end, in terms of connectivity and 5G, let's say what are called holographic communications. Then the aim is also to include mobile edge computing, including, let's say, V2X communication between vehicles. And finally, make use of all the relative sensors, again, and also in this case, like LiDAR, radar, and also cameras, to bring all together, plus also sensor fusion capabilities. So again, you can see that the device itself, developed by HiCONNECTS, will take care of, let's say, higher performance in many different scenarios for many different, let's say, stakeholders as well. Finally, as regards the last scenarios, the idea is to get into the autonomous cars. So this demonstrator will be led by AVL. The idea in this case is to develop, let's say, a demo about a L4 autonomous driving car. In this case, you have, of course, again, the sensing part, like radar parts, LiDARs, cameras, and the like. The information, of course, will go into sensor fusion. The heterogeneous connect device will be take care of the, let's say, high performance radar, as mentioned in the previous slides, but also the connectivity for V2X communications. This demo at the end will also include the decision-making part, so which is also pivotal to achieve level 4 autonomous driving. And with that, I would like to thank you for your attention. As I mentioned before, the project has been funded under the framework of the KDT joint undertaking, and many European countries currently support such a very interesting initiative. If you have any questions, these are my contacts. Happy for any follow-up discussion. Thank you.